All right, hey everyone. So this is our just video review of lesson 9.7, and this one's titled "Will Mr. Gomez Prove Himself?" So this recalls back from some of our previous expectations with Mr. Gomez and if he's a 80% free throw shooter. As always, I'm skeptical and believe that he's a less than 80 free throw shooter. And Mr. Gomez decided to take another simple random sample of 50 free throws to prove himself. So, again, you're going to see me looking over the key and kind of explaining things. This is, again, just to review while you're studying for whatever case. It's not to necessarily experience the lesson, more just to review what you have here. I am going to show you some things on a website that's listed below, just so you can see what's happening here. Now, when we write these hypotheses for a significance test, with P being the true proportion of free throws that Mr. Gomez makes, um, our null is that he is an 80% free throw shooter, and the alternative is that he's a less than 80% free throw shooter. You can see that from um, just the question itself. They're written right there. Now, this requires us to go back and kind of think through 9.6 with our type 1 and type 2 error. So what are we thinking here with a type 2 error in this setting? What we would see here, and I really think, go back and look at your 9.6 quick notes. Type 2 error is that the alternative is true, but we failed to reject the null. So in this setting, it would be that Mr. Gomez is actually a less than 80% free throw shooter, but we failed to find convincing evidence for him being less than an 80% free throw shooter. Now, what we're going to see here, and it's going to be a little messy here, we'll kind of go back and forth here. Suppose that Mr. Gomez's true free throw percentage is actually 66%. This is just an example. We need to, for what we're doing here, we need to have a specific value for the alternative. So we're just picking one here that he's a 66% free throw shooter. Now, we are going to go to this website. I do have it already here. And we're going to look at this type 2 error and kind of talk through some things. We are going to answer these questions of A, B, C, what's happening here. So when we go to that website, we need to do a couple things. First, our null hypothesis value is 0.8. We need to have our alternative is less than, and we're looking at the type 2 error is what we're trying to display. So that's our first step we're going to look at now. And now we're going to look at here the true value of P being 0.66. I think I can get it right in there for us. And you'll see here 0.66 right here, the middle of our blue distribution, which is our alternative. We are going to go back and look. So if the alternative is true, what's the probability of an incorrect decision or a type 2 error? What you're going to see is it's right in here. This P of type 2 error is 24%. Here. Now, if the alternative is true, what's the probability of a correct decision? And this here is looking at our previous 9.6 notes with the smiley faces here. So again, we're going to go back, just look at this. If the null is true, what's the probability of the correct decision? The correct decision there would be that we reject the null hypothesis. It's this number right here, this 76%. So when we reject the null and our alternative is true, that's what we call the power. What you will notice here, the type 2 error probability and the power should add up to 100% or 1 if we're using decimals, which is just written right here. So this is a power here when you know the alternative is true and the probability of making the correct decision. That's what we call the power. So in the terms of the context of this problem, if Mr. Gomez is a 66% free throw shooter, there's a 76 probability, a 0.76 probability, the significance test will find convincing evidence to reject the null that he is an 80% free throw shooter. So what our power is saying here is that if the alternative is true, the power is the probability that a significance test will find convincing evidence to reject the null. Now, what we're going to talk about here, display power. So I'm going to click this, display power. You'll see power is all of this stuff here. And we want to talk about, we want to increase the power of our test. In other words, we want to increase this probability. What do we need to do to these three things of sample size, alpha level, and the alternative P. So first I'm going to look at sample size here, and you'll see as I decrease it, so I'm going to go down extreme to like 5. You'll see our power decreases, and you'll see this overlap between the null and the alternative distributions. Now if I increase, what you'll notice is that the power increases, and at some point it's eventually going to be 100%. We're going to see not a whole lot of overlapping between our null and our alternative here. We can see decrease it, power goes down, increase it, our power is increasing. We also see the probability of a type 2 error increases as sample size decreases, and as our sample size increases, the probability of a type 2 error decreases. So we're going to switch this back to 50. Now, next, let's look at that alpha value. So we were using a 0.05. What if I decrease this down to like a 0.01? So again, I'm going to go back here. I'm just going to show you what happens when we're at 0.5. Here's our power. And as we go decrease, our power also decreases. So if we want to increase that power, the probability of making a correct decision here, knowing that the alternative is true, we're going to have to increase our type 1 error, our alpha value. You can see there that it is increasing. Okay, last thing, let's look at the alternative P. So right now we're 66%. If I increase this to 0.8, we're going to see the power be 5% and having a probability of a type 2 error be really, really high. In fact, eventually it's going to be 1. Obviously, you can think here, if we're less than and our null hypothesis is 0.8, if our true value of P is 0.9, and we're sitting here saying that we're going to reject the null when the alternative is true, we see some conflict here. So let's go down, let's look, what if the true value is 0.3? You see pretty much no overlapping at 0.3. The power is 100%. In fact, if we go to 0.5, we'll see some overlap. We're still going to see basically 100% power here. But as we decrease our P, the true value or our alternative P, our increased distance from the null starts to happen here. As you can see, the null is here, our alternative is here. We're having a decreased distance. When we look at the sample size, what's happening there, let's see, let's put this back to 0.66. Our lower variability in both distributions decreases the overlap. You can see here we have less overlap. We're not spreading further apart. There's just less overlap here. And then finally, when we look at that type 1 error, power requires us to reject the null. That's one of the things. It's the probability of our alternative. If our alternative is the true, there's whatever probability that our significance test would find convincing evidence to reject the null. So that power is requiring us to reject the null. So as we increase this alpha value here, we're going to have a higher probability that we reject the null, which is going to give us a higher power. You can see that's all listed here. So you can see it. And you can go to this website and mess with it. It is kind of neat. There's some more things here just to give you a little bit of idea what's going on. All right, so now let's look just real quick, like some quick notes here. This, again, is the same table from 9.6. If we reject the null and our null is true, we have a type 1 error. If we reject the null and the alternative is true, that's what we call power. Again, that's one of those good decisions. Failed to reject the null and the null is true, a good decision. We don't have any names for that. But if we fail to reject the null and the alternative is true, that's what we call a type 2 error. What you'll notice, again, the type 1 error is your alpha value. That's the probability of a type 1 is your alpha. The type 2 error, this probability is going to be 1 minus your power. So with powers, it's the probability of rejecting the null given that the alternative hypothesis is true. As you can see, a lot of what we're doing here is just some conditional probabilities. They just sound fancier. So how we can interpret this, if our alternative is true, with that specific value and context, there's a power probability of finding convincing evidence to reject our null, and then providing context. The last thing here is just ways to increase power. I mean, it's good to know, but if you're thinking, where's this going to see? It's probably going to be multiple choice. You're going to be asked questions about which ways can increase power. Increasing a sample size increases power. Increasing your alpha value increases power. And then the increasing the distance from our alternative hypothesis, that's the decreasing the true value, the true P. We saw here 0.66. I go down to 0.2. We increased our distance here. That's what that's saying. All right. That was a quick one, I know. But I think it covers the baseline just to remind you kind of your expectations there. So have a good one. We'll see you in the next.